Imagine a cosmic visitor, right? Not some blazing comet, but more like a silent, really enigmatic traveler just slipping through our solar system. What would that even be like?
Well, back in 2017, we kind of got our first taste of that.
Ah, you mean Oumuamua.
Exactly. Oumuamua, it's Hawaiian for scout, or maybe first distant messenger. It paid us this really fleeting visit.
And it was the first one, right? The first interstellar object we'd ever actually detected passing through our neighborhood.
The first confirmed one, yeah. And what's fascinating, and what we dug into for this deep dive using Astrum's great YouTube video, Everything We Know About Oumuamua, is that while it was the first we saw, scientists actually think these things are, well, everywhere.
Everywhere. Like, how common are we talking?
The numbers are kind of wild. Predictions suggest maybe up to 10,000 interstellar objects could be zipping inside Neptune's orbit.
10,000 every single day.
Every day, yeah. It's almost hard to picture.
Okay, so why do scientists think there are so many? Where do they all come from?
Well, you have to think about how star systems form and how they evolve. Our own solar system, for instance, it's got the Oort cloud way out on the fringes.
Right, that huge sphere of icy bodies, potential comets.
Trillions of them, potentially. And they're in these incredibly long, stretched-out orbits. Sometimes, a passing star or galactic tides can nudge them.
Nudge them out.
Some get nudged inwards, becoming long-period comets we see, but others get kicked out entirely, ejected into interstellar space.
Okay, so our system throws stuff out, and presumably other star systems do too.
Exactly. Billions of other stars, each potentially with their own Oort clouds or belts of material. As these stars move through the galaxy, and remember, our sun is moving too, towards Vega currently. They gravitationally interact, they sling their own objects out, and sometimes, very rarely, our sun's gravity might snag one passing by.
But usually they're just too fast.
Way too fast. Most are just passing through, like Oumuamua. Their path gets bent a bit by the sun's gravity, but they're not captured. They just keep going.
Which is what made spotting Oumuamua such a big deal. October 2017, Hawaii, right?
Yep, the Haleakala Observatory. And initially, they weren't sure what it was. First tagged as a comet, C2017U1.
But it didn't look like a comet.
No visible coma, that fuzzy gas cloud. So then they thought, okay, maybe an asteroid. Reclassified it A27U1.
But then its path.
Then they calculated its trajectory. It was hyperbolic, meaning it wasn't bound to our sun. It came from interstellar space and was heading back out.
So a whole new category was needed.
Right. The International Astronomical Union created the I designation for interstellar. So it became 1I-1217U1, the very first I.
The first distant messenger. So beyond just coming from another star system, what else was so strange about it?
Oh, quite a few things stacked up. Its size and shape, for starters. Estimates were like 100 to maybe 1,000 meters long.
Which is big, but the shape.
The shape was inferred from how its brightness changed. It tumbled, and the light curve suggested something really elongated, like a cigar maybe, or possibly a flat disk or pancake shape. Very unlike typical asteroids or comets we know.
Huh.
Like a tumbling space needle or something.
Kind of, yeah. And then there's the origin puzzle. If it's rocky, like an asteroid, it probably came from the inner part of its home system. How does something that big get ejected with such force?
And if it was icy, like a comet?
Then where was the gas? Where was the coma? As it got closer to our sun, any surface ice should have vaporized, outgassed, but we saw nothing.
Okay, strange shape, no gas. But the real kicker was the acceleration, wasn't it?
That was the big one. It zipped past the sun incredibly fast, like 87 kilometers a second at its closest.
Whoa.
But then as it moved away from the sun, it sped up slightly, just a tiny bit, but measurably more than gravity alone could explain.
So something was pushing it, gently.
Exactly. A small non-gravitational acceleration, about 0.17 meters per second squared near the sun, like a very, very faint constant push.
What could do that? Solar wind?
They looked at that, the stream of particles from the sun. But for an object that size, assuming it had normal density, the solar wind just wasn't strong enough. And regular comet outgassing was out because we didn't see any gas or dust.
Right. The Spitzer Space Telescope looked really hard in infrared, trying to catch even a faint heat signature from gas or dust. Found nothing. Zip.
So the conventional explanations just didn't fit.
Which opened the door to some less conventional ideas.
Cue the alien theories. Avi Loeb, right, from Harvard.
Yep. Professor Loeb proposed that Oumuamua might be artificial, specifically a light sail.
A light sail, like propelled by sunlight itself.
Exactly. Solar radiation pressure, it's a real phenomenon. Sunlight exerts a tiny push. Loeb had suggested Oumuamua could be incredibly thin, maybe less than a millimeter thick, but hundreds of meters across.
It's like a giant, super thin sheet.
Yeah, and for something that large and that thin, it seemed unlikely to be natural. So he argued maybe it was technology, maybe alien tech.
That definitely got people talking, but the scientific community was mostly skeptical.
Very skeptical. And alternative natural explanations were proposed. Daryl Seligman, who was at Cornell then, initially floated the idea of a hydrogen iceberg.
Well,
Yeah. Hydrogen ice vaporizes easily and invisibly, so maybe that outgassing provided the push.
but would a hydrogen iceberg even survive the trip through interstellar space?
That was Loeb's counterargument. Probably not. Too fragile, it would likely evaporate over millions or billions of years out there.
So Seligman's idea needed refining.
Right. He teamed up with Jennifer Bergner at UC Berkeley. They came up with a modified theory. The dark comet.
Dark comet.
The idea is it's mostly water ice, but over its long journey through space, cosmic rays bombard it. This radiation can sort of process the water ice and trap pockets of hydrogen gas inside the ice structure.
Okay.
Then as it gets near our sun and warms up, the ice structure changes slightly, releasing that trapped hydrogen gas.
Ah, so invisible hydrogen gas is released, providing the push, but without the dust and other gases you'd see from a normal comet?
Precisely. It neatly explains the acceleration and the lack of a visible coma. It makes Oumuamua not quite an asteroid, not quite a typical comet, but something new, a dark comet.
That sounds plausible. Is that the accepted theory now?
It's a leading contender for sure. But Loeb, as the source mentions, isn't fully convinced. The debate is definitely still ongoing. It's amazing how one object sparked all this.
And it might not be alone. I heard something about similar objects found later.
Yeah, this is really interesting. Since Oumuamua, astronomers have looked back at data and found about half a dozen other small near-Earth objects right here in our solar system that show a similar kind of non-gravitational acceleration.
Without any visible outgassing.
Without any visible signs, yeah. They're much smaller, maybe just a few meters across. Their little speed boosts were probably just missed before Oumuamua made everyone look closer for this kind of effect.
So we might have mini Oumuamuas orbiting nearby, little dark comets.
Could be. And we might get a chance to check one out. Japan's Hayabusa 2 probe after its Ryugu mission.
The one that brought samples back.
That's the one. It's on an extended mission to fly past an asteroid called 1998 KY-26 in 2031.
And KY-26 is one of these weird accelerators.
Apparently so. It's small, rotates fast, thought to be water-rich, and shows this unexplained acceleration. Getting a close look might tell us if it is releasing something like hydrogen, which would strongly support the dark comet idea for Oumuamua too.
So even though Oumuamua itself is long gone, we might solve its mystery by studying its local cousins. That's pretty cool.
It really connects the dots, doesn't it? And reminds us that Oumuamua, while the first confirmed interstellar visitor, wasn't the only one. We later found 2I Borisov.
Which was much more like a regular comet, right? Big fuzzy coma, tail.
Exactly. Showed a lot more diversity among these interstellar travelers. And it's not just stuff coming in. Objects leave too.
Like that comet kicked out by Jupiter.
Yeah, C1980E1. Used to be ours. Now it's interstellar bound thanks to Jupiter's gravity. And the reverse might happen too. Maybe some weird comets in our system were actually captured from interstellar space ages ago.
And that asteroid orbiting backwards.
Kaishu, yeah. Asteroid 514107 Kachine. Its retrograde orbit strongly suggests it didn't form with the rest of the solar system, but was likely captured after wandering in from interstellar space.
Maybe it was a comet that lost all its ice long ago.
So our solar system is like this cosmic highway interchange. Stuff coming, going, sometimes getting stuck here.
Pretty much a dynamic place. But trying to actually go visit Oumuamua now, that's a whole other challenge.
Yeah, where is it now? Really far away, I assume.
Oh, yeah. Over 6 billion kilometers away by now, still moving at about 26 kilometers per second, and finding its home star. Tricky. Potential candidates are up to 80-odd light years away.
And catching it seems almost impossible.
Extremely difficult. You'd need incredible speed to catch up, then you'd somehow have to slow down once you got there. And just finding that tiny object again in the vastness of space, it's tough.
But people are thinking about it. Project Lyra?
They are. Project Lyra looked at mission concepts. Really ambitious stuff. Using multiple gravity assists, Jupiter, Venus, Earth slingshots, maybe even a solar O-berth maneuver. What's that?
You dive really close to the sun, then fire your engines at maximum velocity using the sun's gravity well to get a massive speed boost. Highly efficient, but technologically, very demanding.
Heat shields, complex maneuvers.
Exactly. We're talking maybe launching the early 2030s to arrive in the late 2040s. A long trip.
So maybe better just to wait for the next one, with better telescopes coming online.
That's probably the more practical approach for now. The Vera C. Rubin telescope, starting soon, is expected to find potentially many more Oumuamua-like objects every year. We'll get more warning, more time to observe.
And that European mission, Comet Interceptor.
Right, ESA's Comet Interceptor,
Yep.
launching around 2029. It's designed to basically park in space and wait. If a suitable interstellar object comes along on the right trajectory, it can be sent to intercept it.
Like having a probe ready on standby. That's clever.
It is. But it all comes back to that fundamental question, doesn't it? Is chasing these sleeting mysteries, these interstellar messengers, worth the huge effort and cost?
It's a good question. So wrapping up our deep dive today, Oumuamua definitely left us with more questions than answers, didn't?
Absolutely. Interstellar origin, that bizarre shape, the weird acceleration. Was it a dark comet? Alien tech? Something else entirely? We still don't know for sure.
But just its brief passage, it feels like it shifted something. It opened up this whole new area of thinking about, traffic between stars and the sheer variety of objects out there.
It was a wake-up call, really. A reminder that our solar system isn't isolated. It's part of a much bigger, dynamic galaxy, and these encounters, however brief, can tell us so much.
So, considering Oumuamua just zipped past us so quickly, it makes you wonder, what other silent stories are unfolding out there? What else is drifting through our cosmic neighborhood, just waiting for us to notice?
The universe is full of surprises. Oumuamua was just the first confirmed hello from way out there.
Definitely makes you want to keep looking up.